Welcome back again, everybody. Today we are doing simultaneous equations. Bit like all these simultaneous videos that have come out about maths. I'm sure you're probably a bit bored now if you've been watching them all, but that's fair enough. We're going to do simultaneous equations. Alright, simultaneous equations are where you have two, well commonly two, I'm just going to look at two, you can have more, but yeah, two's the standard. Two equations, and you need to work out what two, or sometimes more, but it's usually two unknowns are based on those two equations. So an example of a simultaneous equation could be 3x plus 4y equals 5, and then 4x minus 2y equals 14, and you've got to find what x and y are. So there's two methods that we're going to look at separately, and we're going to look at how to use them, and basically, yeah, an example of both. So firstly, we're going to start off with the substitution method. This is, I should just cover briefly, the reason that simultaneous equations are most commonly used is in questions where you think the only thing that you can do is guess and check. So these simultaneous equations are done so that you don't have to guess and check. Right, so the first one is going to be the substitution method. This is basically where you make one of the equations be equal to either x or y. So you get what one of the unknowns is equal to in terms of the other one. For example, y could be equal to 3x plus 5 after you rearrange it. And then you sub into the y in the first equation, 3x plus 5. And then you get that answer there. Okay, so that's basically what the substitution method is. I'm going to go through an example now. So the example that we've got here is the first line of the equation is 2 plus 3y equals 5. And in the second line, we've got, it was 2x plus 3y equals 5. And in the second line, we've got y minus 3x equals 9. So in order to make y the subject there, we have to rearrange it till we get y equals 9 plus 3x. So now we've got what y equals, we can do that in the front one. So what we can do is we know that y equals 9 plus 3x. So wherever there's a y in the first line, we can sub that in for 9 plus 3x. So we've now got 2x plus 3 times 9, which is 27, so plus 27. And then also plus 3 times 3x, which is 9x. So what we equals 5. So what we're going to get there is we're going to get 11x plus 27 equals 5. So we're going to use standard rules of solving equations. So we're going to minus 27 from both sides. So now we have 11x equals negative 22. Divide both sides by 11 to get x, which is equal to negative 2. Now that we've got x, all we need is y. And we already worked out before that y is equal to 9 plus 3x. So we go y is equal to 9 plus negative 6. 9 plus negative 6, which is means that y is equal to 3, because that's 9 plus minus 6. Y equals 3. Boom. That's done. That's a really good method. It's a nice one to use. The next method is the elimination method, which I also really like. I think it's a good one, but it only works well in some scenarios, like in terms of easiness. So the equation that we've got here is 3x plus 2y equals 12. And then the second line is 3x minus y equals 3. So as we can see here, both equations have a 3x. And if you don't have ones that line up, you can always do something to both sides of one equation to make it. So for example, there we've got a 3x minus y, and in the top line we've got a 3x plus 2y. So if you really wanted to do the two y's, you would have to times the negative y by a negative 2, then you have to times the 3x by a negative 2, and the 3 on the other side by a negative 2. But that's just a lot of extra effort. So what we're going to do is, as we can see, we have the two 3x's, one in each line, which means that we can use them to sort of cancel them out. So what will we need to do in order to make 3x, what sign would we need to put between two 3x's to give 0? Well, because they're both positive, the answer is a minus sign. So we've got 3x plus, so 3x minus 3x is equal to 0. So what we do is we minus one equation from the other. We get 0, because that's the 3x minus 3x. And then it's plus 2y minus y, because we said that we were minusing, and then there's a y down the bottom, and then that's equal to 9, which is 12 minus 3. And so then 2y minus y is equal to 2y plus y, which is equal to 3y. So we say 3y equals 9, which means that y equals 3. Then once again, you can just sub it in wherever you want. We will use this bottom line, 3x minus y equals 3. And because we know that y equals 3, we can say 3x minus 3 equals 3, plus 3 to both sides, 3x equals 6, x equals 2. Boom. That is how you do simultaneous equations. I won't do any more examples or practice questions in this video because that's basically the method, but you may have to watch it over again if I was speaking too fast. But I'm sure there are plenty of practice questions that you can find. Just Google simultaneous equations questions, and you can pick and choose these methods. Personally, I prefer the elimination method, but if it was one of those situations like I was talking about where you'd have to times everything by weird amounts in order to make it eliminationable, then I would recommend doing the substitution method. So just do whichever one works better for you and whichever one is going to get you the right answer quicker and more, what am I trying to say? And more effectively, so it's going to work the majority of the time. So thank you. I hope you enjoyed. Thanks for tuning in. If you did enjoy, make sure to like and subscribe and catch all of our other maths videos because we have a lot coming out at the moment. So thank you and goodbye.